chapters in bio, 4 or 5 chapters in chemistry. Probably this is what was there. And you had 1 book in maths. But understand, when you get into the 12th, in every entrance exam, you will have 11th syllabus and you will have 12th syllabus. Then in 11th syllabus, there is 1 book for maths. Then there are 2 books for physics, 2 books for chemistry, 1 book for biology. In 12th again, there are 2 books in physics, there are 2 books in chemistry, there is 1 book in biology, 1 book in maths. So depending on whether you're going for PCM or whether you're going for PCB, there is a lot of portion to read. You will have to read both your 11th portions and the 12th portions. It's not that it is going to be this or this. So in your 10th, you had only 1 syllabus that you had to read. Okay. So when you look at all these things, definitely 11th will be a little bit more difficult than 10th, much more difficult than 10th. Also in 11th standard, we do little bit more rigorous maths. Whether whatever exam you are going in for, you will need little bit of maths. So that is one very important thing that we will have to understand. Okay, so what I'm going to do today is I'm going to revise you 1 chapter called trigonometry. Okay, now when you go to 11th and 12th, especially in the physics, we will require a lot of trigonometry. So these 3 areas of maths we will need. One is trigonometry, second is coordinate geometry, and the third is calculus. While calculus you will be reading in your 11th and 12th, coordinate geometry also you will be reading. Of course, trigonometry also you will be reading, but right now we will just revise the portions that you have learnt in your 11th standard. Okay, so that is going to be our aim. So I'll work out some small things for you. Please make notes and then again try to work. There is a book called Trigonometry by S.L. Loney. Trigonometry by S.L. Loney. This can be freely downloaded from the internet. There are 2 volumes of this, volume 1 and volume 2. This book was again written 100 years before, 100 plus years before. So it's a very, very old book. So the terminology, some of the terminologies used are very old, but still it is a good read. It is a good read for you. Okay. If you do this book, it will help you. It will help you. It is easy. It is at the 10th standard level. It is easy, but it is a good read. Now in the summer, before your classes start in the school, it is a good read. It will give you a very good foundation if you understand that trigonometry. Okay. So fine, I will move on. So I will try to talk about trigonometry. So in trigonometry, basically at our 10th level, we are talking about triangles, and that too we are talking about right angle triangles. So here is a right angle triangle. In any right angle triangle, I have named ABC. ABC are the 3 sides of the right angle triangle. ABC are the 3 sides of a right angle triangle. Then we know that in any triangle, sum of all angles, sum of all interior angles is 180. Then sum of all exterior angles is 360. So I hope we understand this. Interior angles, this angle is interior, this angle is interior, this angle is interior. Then there are 2 types of triangles. You can have acute angle triangles and you can have obtuse angle triangles. Yeah, acute angle triangles, if all the angles are less than 90, we will call it a acute angled triangle. Then if one angle is more than 90, we will call it an obtuse angled triangle. So these are simple things. You have already read this before. Acute angled triangle and an obtuse angled triangle. Okay. Then we have also read about right angled triangles. Right angled triangle basically refers to a triangle where one angle is 90 degrees. All the trigonometry that we have learnt in school is focusing on right angled triangles. So we will start with right angled triangles and then slowly we will generalize our approach. So suppose this is a right angle triangle. It looks like one. So I have ABC is a right angle triangle, right angled at B. Now side opposite to B, angle B is side B. Side opposite to, this is angle A, side opposite to angle A is side A. Side opposite to angle C is side C. Do we understand this? Yeah, so we understand side opposite to angle A is side A, side opposite to angle C is side C, and side opposite to angle B is side B. Then because it's a right angled triangle, Pythagoras theorem is valid. And if Pythagoras theorem is valid, then I'll have A squared plus C squared is equal to B squared, or AB squared plus BC squared is equal to AC squared. Do we understand this? A squared plus C squared is equal to B squared. That is adjacent side plus, so this angle is, suppose you take this angle, the C is the opposite side. So this is the adjacent side. Adjacent side plus opposite side squared. Adjacent squared plus opposite squared is equal to hypotenuse squared. This is not equal to A plus B the whole squared, or A plus C the whole squared. A plus C whole squared is A squared plus C squared plus 2AC. So here this 2AC is not there. So here we are simply saying A squared plus C squared is equal to B squared. This is what we are applying Pythagoras theorem. Now this is very simple. Now we are defining some trigonometric angles, okay, or trigonometric ratios. Trigonometric ratio, for suppose we are talking about angle C, I can say sine C is equal to opposite side by hypotenuse. What is opposite side equal to? C. What is hypotenuse equal to? B. So sine C is equal to C by B. Okay. Now the same way, if I go for sine of A, sine of A is equal to opposite side. All sines are opposite side by hypotenuse. So that will become equal to A by B. A by B. Then you have, yeah, so you have this, right? So similarly, I can now talk about other trigonometric ratios. What are the other trigonometric ratios? I can talk about cosine. Cosine is usually written as cos. So cos C is equal to adjacent side by hypotenuse. Then I have tan C. Tan C is basically standing for tangent. So tan C is equal to opposite side by adjacent side. Yeah, can you make some notes about this? Then you have cosine. Cosine C is equal to 1 upon sine C. Similarly, you have secant. Secant C is usually written as, this is written as cosecant. Okay, so I'm sorry, this is not cosine, this is cosecant. Okay, I'll take a new page and explain again. So you have sine, which is written as sine, S-I-N-C. Then you have cosine, usually written as cos C. Then you have tangent. This is written as tan C. Then you have cotangent. This is written as cot C. Then you have cosecant. It is written as cosec C. Then you have secant. Okay, so as per the triangle that we had it like this. So we had A here, we had B here, we had C here. So this angle is C. So opposite side. So I said this is angle A, side A. This is side C. This is side B. So secant C is equal to C by B. Cosecant C, cos C is equal to A by B. Tangent is equal to opposite side by adjacent side. So that will become equal to C by A. Cotangent is equal to the reciprocal of this, 1 by tan C. So that is equal to A by C. It is adjacent side by opposite side. Cosecant is cosecant is same as 1 upon sin C. So that will become equal to B by C. Secant C is same as 1 by cos C, and that is equal to B by A. Okay, so can you make some notes on these? These are the different trigonometric ratios. You would have already learned this in your 10th standard. Maybe even earlier, some of you might have learned it even in 9th standard. So these are the different trigonometric ratios. We are talking with respect to a right angle triangle. With respect to a right angle triangle, if I apply Pythagoras theorem, I have a squared plus c squared is equal to b squared. Okay, so once you get this, then we will move on. Okay, so once you understand this, then let's move on. So what people did is people drew different types of right angle triangles. They drew right angle triangles. They marked this angle as 60 degrees, and then they found out the different trigonometric ratios for 60. Then they found out different trigonometric ratios for 30, and they found out the trigonometric ratios for all possible angles. Right? I hope you are also aware of these trigonometric ratios. So suppose I talk of 0, suppose I talk of 30, then I'll talk of 45, then I'll talk of 60, and then I'll talk of 90. So these are the standard trigonometric ratios that you should be aware of. So I should be aware of sine. So sine 0. So sine 0 is how much? 0. Sine 30 is half. We have to memorize this. There is nothing else that we can do. You already, most of you might be knowing also. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. Then sine 90 is equal to 1. So this is the trigonometric ratios with respect to sine theta. So sine theta, so if theta is equal to this much, what is theta? Theta is an angle. Okay, in our lower classes, we talk in terms of angles in degrees. But when you come to 11th and 12th, they won't talk in terms of degrees. They'll talk in terms of radians, which I will explain to you in a few seconds or a few minutes. Okay, so first, I hope this one all of you understand. Next, we will go to cos theta. So cos theta, cos 0 is assumed to be or is 1. Then again cos 30 is root 3 by 2. Cos 45 is 1 by root 2. Cos 60 is half, and sin cos 90 is 0. How did people learn all these things? They drew different types of triangles. So they drew triangles. So you are worried, okay, how can cos 0 be equal to 1? So now I am talking of a right angle triangle where the angle is almost equal to 0 degrees. This angle is almost equal to 0. So if this angle is almost equal to 0, do you see that both this is A, B and C? Do you see that A, B is almost equal to BC? Yeah. So adjacent side by hypotenuse will be equal to how much? 1. So that's what they are trying to say. So you can argue, how can you draw a triangle where one angle is 0 degrees? So how do I do it? I'm not doing it. I'm going to very close to 0. And then I'm seeing how it is behaving. And then I found it out. Okay. So can you make notes? Then I have tan theta. Okay, tan theta is also equal to sin theta by cos theta. Sine theta by cos theta. So tan theta, if theta is equal to 0, sine theta, sine 0 is 0, cos theta is 1. So how much is tan theta going to be equal to sine theta by cos theta? So that will equal to 0. How much is tan 30? Tan 30 will become 1 by root 3. How much is tan 45? This by this will be 1. How much is tan 60? Tan 60 will be root 3. Now tan 90 will become 0 by 1. Sorry, 1 by 0. And 1 by 0 will be a very big number. We will say undefined. So we will say it is infinity. For us, infinity has two meanings. Yeah. In our 11th standard, infinity has two meanings. Something which is very, very big. Very, very big. And is also has a meaning undefined. You can't find out. 1 upon 0, 2 upon 0, 3 upon 0. You cannot find out. This is not defined. Because it is not defined, sometimes we say it is equal to infinity. Okay. So we use this word infinity in two ways. In two different contexts, we use this word infinity. So please make sure that we understand which context is used where. Huh? So if something is not defined, we say it is infinity. If something is very, very big, also we say it is infinity. Now here it is left to the individual to be able to understand what we are talking of. Now you may ask, sir, how can you say 1 by 0 is infinity? Yeah, so I don't know what 1 by 0 is. Because I don't know what it is, I put it as infinity. If I'd known what it was, I would have given a number. When I gave a number for each of these other things which I knew, so here I would have given a number, but because I don't know, I am not giving a number. I just put it as infinity. Okay, then you have cosecant theta. Cosecant theta is equal to 1 upon sine theta. Cosecant theta is 1 upon sine theta. So if it is 1 upon sine theta, 1 upon 0, 1 upon 0 is infinity. Then cosecant 30 is 2. Cosecant 45 is root 2. Cosecant 60 is 2 by root 3. And cosecant 90 is equal to 1. All these things I hope we know. Then I have secant theta. Secant theta is same as 1 upon cos theta. Secant theta is 1 upon cos theta. So when you say it is 1 upon cos theta, then I'll have 1 upon cos theta, 1 upon 1. Then I'll have 2 by root 3. Then I'll have root 2. Then I'll have 2. Then I'll have 1 upon 0. 1 upon 0 again, I don't know what it is. So it becomes infinity, undefined. Okay, so these are the trigonometric ratios of standard angles which you should know. I have written the angles in degrees, but I explained to you that in 11th and 12th they will not talk in terms of degrees, they will talk in terms of radians. So I will quickly explain to you how these can be converted to radians and vice versa. Okay, today I'm just telling you the basics. Subsequently, we will get into more complicated things. So see, one thing is that trigonometry for you comes from a triangle. But in 11th, trigonometry doesn't come from a triangle, but it comes from a circle. It doesn't mean what you have learnt is wrong. It means that you have learnt the most simplistic explanation of sine theta. Now there are other possible explanations of sine theta without really affecting or without really proving what you have learned to be wrong. Okay, so I will explain to you the meaning of sine theta, but that's not important for us today because I'll keep explaining this again to you in the next class also. But what is important for us today is to understand that trigonometry has a much larger meaning beyond what is there in case of triangles. Okay, so sine theta. So I'll explain to you the meaning of sine theta. Now suppose you take, this is a coordinate axis. This is the x-axis. This is the y-axis. Okay, you take a line. Suppose this line has some length L, and you rotate that. You rotate it. So when you are rotating it, it will move in a circle. My diagram doesn't look like a circle, but you draw a diagram which looks like a circle. Okay. So suppose at some instant of time, the rod is here. So this angle is theta. Now suppose I throw light from this side. I throw light from this side. Do you understand that it will create a shadow here? So this is the shadow, or this is the shadow. So the length of shadow on y-axis divided by the length of the rotating rod is basically sine theta. Okay. Now we don't talk about shadow also. So this is what is referred to as a projection. Technical term is projection. So sine theta is actually projection of a vector, radius vector, a complicated definition. We don't know what is a vector, we don't know projection, but I'm just simplifying it again. So projection of a radius vector on the y-axis is referred to as, of a unit vector is referred to as sine theta. Now what it means is that if you take a rod of length 1 unit and then you are rotating it, the projection on the y-axis, projection is nothing but the length of the shadow. That length of the shadow will give you the value of sine theta, where theta is the angle which the rod makes with the x-axis. Yeah, so this is a complicated definition. I'll take a new paper and then show this. So this is the coordinate axis. I have taken theta, and then I'm taking the rod and I'm rotating it. At some instant of time, the rod is here. At some instant of time, if the rod is here, this angle here is theta. Now I have taken this rod of length 1 unit. So this rod is now forming a shadow here. It is equal to this. Now the length of this shadow is basically sine theta. So sine theta is equal to, what is the length of this? 1. So the length of this shadow, whatever it is, length of projection divided by 1. So do you see that it is opposite side by hypotenuse? So what you have learnt is not wrong, but what you have learnt is limiting. It is limiting because I can't think of a triangle. I can think of a triangle where one angle is 90 degrees, but I can't think of if this angle is 90 degrees and this angle is theta. So sine theta, theta will always be less than 90, because I can't think of a triangle where one angle is 90 and another angle is more. Yeah, but the moment I think of a circle, now my rod is here and I found out the projection. What if the rod is here? Again I'll get a projection, and this time this is the angle. Then what if the rod is here? This time this is the angle. Then the rod can be here, right? Then I can have this as the angle. And some of you might want to say, sir, why are you taking this? Why not take this? So do you understand? So the moment you talk of a circle, now we can talk of angles more than 90 degrees. Okay, we won't talk about it right now. That's not important for us right now. We will come to it. All that I want to communicate is that, look, sine theta or cos theta has a much greater meaning than opposite side by hypotenuse or adjacent side by hypotenuse. Okay, so these have greater meanings than just this, and we are going to look into all these things. Okay, so first, why do we call trigonometry also as a case of circular functions? So you will read more about functions, you will read what is a function, you will read, but you have learned polynomials, you have learned p of x is a polynomial. Same thing I can say f of x is a polynomial. So the same way I can say f of x, if f of x is something like sine or cos or something, I can say that look, this is a function. So anyway, forget about what functions are, but right now understand that trigonometry has much greater meaning than angles or the geometry of a triangle. And we will learn trigonometry with respect to a circle. Now, if you know this is a circle, and what is a circle? Full circle. Full circle is 2 pi r is the length of the circle, length of circumference. So circumference of circle is 2 pi r. So if circumference of circle is 2 pi r, then can I say that if r is 1, the circumference is 2 pi? Or can I say that the circumference of a circle or a circle represents 2 pi radians? 1 radian is basically the angle represented by an arc of size 1 radius. If you look at full circle, a full circle has 2 pi r. This full length is 2 pi r. Okay. Now, if this angle here is theta, for what will be the value of theta if this arc length is 1? So if that arc length is 1, if I divide it, it will be, it will be 1 radian. And one full circle is considered to be 2 pi radians. So circumference is 2 pi radius into radius. This is the total radius. If you take one arc of radius length, the angle represented will be 1 radian. So 1 radian is is equal to 360 degrees. See, this full circle is 360 degrees. Now 360 degrees is equal to 2 pi radians. So 1 radian is equal to 360 divided by 2 pi. That is 180 divided by pi. Pi is approximately 22 by 7. So 180 by 22 into 7. So something close to 53-54 degrees will be 1 radian. So we are talking about this measure of an angle. Angles are measured in terms of radians. And for us, one circle is equal to 2 pi radians. One circle is equal to 2 pi radians. Because it is 2 pi radians, the total circumference is simply equal to 2 pi r, where r is the radius. So can we make some notes here? So one circle is equal to 2 pi radians. So 360 degrees is equal to 2 pi radians. So 60 degrees is what? 60 degrees is 360 by 6. So it is equal to 2 pi by 6. So 2 pi by 6 means it will be equal to pi by 3 radians. Is equal to pi by 3 radians. Can you make some notes here? I will tell this to you again. Okay, first let us make notes here, then I'll go back there. So one full circle, 360 degrees. 360 degrees is captured in 2 pi radius. So we say 2 pi radians is equal to 360. So from there I can find out 1 radian. 1 radian is equal to 360 by 2 pi degrees. So now this gives me a clever way of comparison between degrees and radians. Degrees and radians. So if I have 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, then again 120 degrees, then again 180 degrees, then again I can have 270 degrees, then I can have 360 degrees, then 0 degrees. 0 degrees is 0 radians. 330, 30 is how much? 30 is 360 by 12. So 360 is 2 pi. So this is equal to 2 pi by 12. So 2 pi by 12 is pi by 6. So 30 degrees is pi by 6 radians. Another easy way to calculate 360 degrees is 2 pi radians. So 180 degree will be pi radians. 90 will be pi by 2 radians. 45 will be pi by 4. So this is 360 by 2 is pi. By 2 I came to 90. By 2 I came to 45. Yeah. Then this is 360 by 6. So it will become 2 pi by 6. 2 pi by 6 is pi by 3. Now 120 is double of 60. So this will become 2 pi by 3. 270 is 3 times pi by 2. So it will become 3 pi by 2. So this is how you can convert degrees. So 75 degrees is how many radians? So 360 degrees is 2 pi radians. So 180 degrees is pi radians. So 1 degrees is pi by 180 radians. So 75 degrees is pi by 180 into 75. Now I can calculate that and get you the answer. So 5 will go 15 times, 5 will go 36 times. Again 3 will go 5 times, 3 will go 12 times. So it is 5 pi by 12. So 75 degrees is 5 pi by 12 radians. Okay, can you make some notes here? Hmm, 5 pi by 12. So this is how you can convert from one to another. So I'll give you some small work. So convert the following. Convert the following to radian measure. Convert the following to radian measure. First one, 15 degrees. Second one, 72 degrees. Third one, 150 degrees. Fourth one, 210 degrees. Then fifth one, 300 degrees. So please convert all this to radian measure. Please convert all this to radian measure. So I'll wait for 2-3 minutes. Then I will do it for you. So if I can work it out here, I'll work it out. So 15 degrees. So 15 degrees, let me see. I understand that 360 degrees is 2 pi radians. So 1 degree is 2 pi by 360 into 15. So 15 degrees will be 2 pi by 360 into 15. So this will become 180 here. So 15 once 15, 30, so 12. So it is equal to pi by 12. Then calculate 72. So 72, I didn't tell you, basically 360 is 2 pi. So 360 by 10 will be 2 pi by 10. So that is 36. So 72 is 2 into 36. So it will become 4 pi by 10. 4 pi by 10 will make it 2 pi by 5. So 72 degrees is equal to 2 pi by 5 radians. 2 pi by 5 radians. Then you have 150 degrees. 150 degrees. So the same way, so it becomes 2 pi by 360 into 150. So that is equal to 0, 0 cancels here. Here it becomes 18. 3 will go 9 times. 3 will go 5 times. So 5 pi by 9. So 150 degrees is equal to 5 pi by 9 radians. Similarly, 210 degrees. 210 degrees. 210 degrees is equal to how much? So 210 degrees is equal to 2 pi by 360 into 210. So 0, 0 gets cancelled. 2 will go 18 times. So pi by 18 into 21. So 3 will go 6 times. 3 will go 7 times. So it is equal to 7 pi by 6. Now here you don't have to multiply it by 2. So pi is 3.14. So you don't have to multiply it by that and say. If you say it is 7 pi by 6, express it in terms of pi, it is enough. Remember that pi is equal to 22 by 7 is an approximation. Pi is not equal to 22 by 7. Pi is an irrational number. Irrational number means it's a non-recurring, non-terminating decimal. So it is not a rational number. 22 by 7 is a rational number. Pi is not a rational number. So pi is closest to 22 by 7. Pi is not equal to 22 by 7. So we are, when you are expressing angles in radian measure, we are simply specifying that it is so many pi. Okay, so the answer is given in terms of pi. Okay, so next is 300 degrees. 300 degrees, already we found out 150 degrees 5 pi by 9. So 300 degrees will become 10 pi by 9. So this is how you can convert angle measure to radian measure. Angle measure to radian measure. How do you calculate? Understand that 360 degrees refers to 2 pi radians. So 1 degree is referred to 2 pi by 360. So x degrees will be 2 pi by 360 into x radians. Okay, so this is how you can convert angles to radians. Now, how do you convert radians to angles? So 2 pi refers to 360. So pi refers to 180. So 1 radian refers to 180 by pi. So whatever is x will refer to, x radians will refer to 180 by pi into x degrees. So if you're talking about pi by 6 radians, we refer to 180 by pi into pi by 6. Pi cancels, so it is 30 degrees. If you're talking about 2 pi by 3 radians, so it is 180 by pi into 2 pi by 3 degrees. So pi cancels through 360 by 3, so that is equal to 360 by 3 is 120 degrees. So you should be able to convert angles to radians and radians to angles. So this is how you convert radians to angles. 180 by pi into radians will give you degrees. We will be using this concept in physics quite a bit. So please make sure that we are able to understand this. Okay. So if you understand this, then we will move. I told you I will explain the definition of sine theta again. So let me just define sine theta as per what it is modern in the modern mathematics. Consider a rod of length 1 meter rotating about a point with an uniform, all this is not required, angular velocity. The projection of the rod on the y-axis is sine theta, and on the x-axis is cos theta, where theta is the angle made with the positive direction of x-axis. The projection of the rod on the y-axis is sine theta, and on the x-axis is cos theta, where theta is the angle made by the positive direction, made with the positive direction of the x-axis. So I'll explain again. So here, this is the rod, and this rod is rotating this way. So at some instant of time, the rod is here. So if the rod is here, projection refers to a shadow. So if there is a perpendicular light here, the shadow will be formed here. If there's a perpendicular light here, there's a shadow here. So this is the projection on x-axis. Projection on x-axis. This is the projection on y-axis. So the projection on y-axis refers to sine theta. The projection of x-axis refers to cos theta. Remember, this is a length 1. So I can say it is the ratio of the projection on y-axis to that of the length. So the sine theta, cos theta, these are all ratios. So the ratio of the projection, because this is 1, the projection and that will be the same, just that it will not have any units. Okay, so this is what is sine theta and this is what is cos theta. What is theta? Theta is the angle made by the rod. This is the positive direction of the x-axis. So it is this angle. If the rod is here, you will have doubt whether it is this angle or whether it is this angle. Is it the smaller angle or is it the longer angle? Now remember, angles are always measured anti-clockwise. Angles are always measured anti-clockwise. So it is this angle. But I can say this also. If I say that, then I have to talk of the negative angle. Angles are always measured anti-clockwise. So it is this big angle that we are talking of. But if you are talking about this angle, the clockwise angle, then it becomes minus. What I'm now trying to tell you is that, look, trigonometric ratios also exist for negative angles. If you are just measuring the angle in a clockwise way, it becomes negative. So this is where you see the horizon of trigonometry becomes much larger. You can apply trigonometry to much greater sense than triangles. And now I can imagine cos not just up to 90 degrees, but I can imagine cos 120. I can imagine cos 240. I can imagine cos 360. I can imagine cos 720 also. Because these are circular functions. If I go 2 times on the circle, it comes to 360. But if I understand trigonometry as the ratio of sides of a triangle, of a specific triangle, then I can't imagine 120 degrees. I can't imagine a right angle triangle where one angle is 120 degrees. Do you understand? So we need to understand the greater application of trigonometry and the larger definition of trigonometry. In this particular definition, I have made it simple for you by not using the word ratio. To that extent, this is inadequate. I should say it is equal to the ratio of the projection of the rod on the y-axis to the length of the rod. It is the cos theta is the ratio of projection of the rod on the x-axis to the length of the rod. But here I have made it simple by considering the length of the rod to be 1 meter. Okay, otherwise by whatever I have written here, you may get a confusion saying projection of the rod on the y-axis. So any projection is a length. So you will ask, sir, does sine theta have a dimension, have units of length? No, sine theta is a ratio. It's a ratio of projection of the rod on the y-axis to the length of the rod. To the length of the rod. To that extent, this definition is inadequate. But my idea is that you just start thinking about it. Slowly, our definitions will be complete. Slowly, we will say whatever we want to say perfectly. But we have to first give the mind the scope of understanding, give the mind the scope of thinking. So my aim today was just to make you think that angles are measured in terms of radians. And 1 radian, to be precise, see, full circle is 2 pi radians. So 1 radian is the angle measured by a circumference, by an arc of 1 radius. So if you have an arc, if you have a circle here, and you start from here, if you go 2 pi such things, you will go 360 degrees, right? So 1 radian is basically that angle which is subtended by an arc of length, 1 radius, so that a full circle will have 2 pi radiuses. So the length of the full circle will have 2 pi radiuses. Okay, so my aim today was, one, to explain to you that there is something called as radians, explain to you that angles are measured in terms of pi, so pi by 2, pi by 3, pi by 4, whatever. And the second thing is that the sine theta, cos theta have a much larger meaning than what we have perceived so far. Yeah, what we have perceived so far. So I want you to go back with this thinking, and we will think more and work more in the next class. Okay, so tomorrow, I think every alternate day you will have the physics classes, maths classes, and so on. So yeah, so tomorrow you will have chemistry class, and tomorrow one day let there be an uncertainty. I'm not sure if you'll have a chemistry class and a physics class, or a chemistry class and a maths class. The next class is a maths class for you. I think maths sir is going to start with quadratic equations. So he wants to teach you quadratic functions. So he will be discussing quadratic equations. That's what I think he will do. But anyway, slowly we will move on, and then maybe within another 5-6 days, or maybe 10 days, you'll see you'll be learning all new stuff. Okay, and this new stuff is just a continuation of whatever you have learned in your 10th, just that we are going to look at it in a different light. Okay, fine. Thank you. So see you again. Okay, some students want to see all the slides again, so I will show the slides again. So those of you who have missed it can take a screenshot, and then you can work. So here, slide 1. This book is a good book. It's only up to 10th level. Volume 2 is of no use. Just read volume 1, should be enough. So I was talking about trigonometry, some basic properties of a triangle. So Pythagoras theorem, definition. I made some small mistake here, so I said, okay, let me just explain it again properly, neatly here. So this is the thing. Then we found out trigonometric ratios for angles. This is something that all of you should remember, commit it to memory. Then I moved ahead and I was trying to explain to you about circular functions. I was trying to explain to you that trigonometry is not as simple as a triangle. There is much more to it. So I was explaining to you the meaning of sine theta. So here I was trying to teach you how to convert from radian measure to angle measure. So we did some small conversions, and I explained to you how to go ahead with it. I gave you a few questions. Then I asked you to convert all these degrees to radian. Then I gave you a few radians and I asked you to convert to degrees. Very rarely we will convert radians to degrees, but mostly we'll be converting degrees to radius. We'll be converting degrees to radians, because in my mind, in our minds, we know sine 60, but we may not know sine pi by 3. So we'll always be converting, especially initially. In your mind, you'll be converting. So converting from Radians to degrees is very important, more important than converting from degrees to radians. This hardly we will use. Then I was trying to give you the definition of sine theta. I will do this perfectly again in the next class, and we'll be working on this again in the next class. There will be repetition. Yeah, so that's it. Work hard. All the best. Answer is wrong for 150 degrees. Oh, let me see. Let me see 150 degrees. Okay, I just tell you how to convert 150 degrees. So 360 degrees is 2 pi radians. So 1 degree is 2 pi by 360 into 150. So cancels, 12 will go 5 times, 12 will go 3 times. Sorry, 3 will go 5 times, 3 will go 12 times, this will go 6 times. So 150 degrees is 5 pi by 6. Okay, if I made an error, please rectify. Yeah, you work with your notebook, so don't go by the answers that I give. So please work and you get it. So if 150 degrees is 5 pi by 6, 300 degrees will be 10 pi by 6. Okay, 2 times that much. Yeah. Okay, thank you.